Yes, and my name is Carlos Santana. And no, I don't play the guitar. Um, so yeah, great conference. I'm meeting a lot of people. Who's from North Carolina? Here from the Triangle, okay? How long have you been here? More than 5 years? More than 10 years? More than 20 years? Okay. I've been living here for more than 20 years. I moved from Puerto Rico, and the promise to my mom was only going to be 2 years, but that was more than that. But let's talk about a few things that I like about Raleigh, moving here in North Carolina. If this thing works.
Is it turned on?
Let's see. Okay. So, yeah, we always have an agenda. So today we're going to talk about the data in your applications. For the most part, we've been talking about stateless applications, but this talk, I wanted to talk about data in your application. GitOps for infrastructure, which is a new kind of term or paradigm. It's also related to platform engineering. And then disaster recovery, which I think all the DevOps engineers and SREs have to deal with it. But what I was going to say was that one of the things that I really like from North Carolina, that when I moved here, was going out and picking up fruits like strawberries and apples. Those are type of fruits that I don't have back home the pleasure to pick up, like we had avocados and mangoes and those type of things. But apples and strawberry is something that I tasted for the first time picking up them here. And one of the things that my family likes to do is go out and take a lot of pictures. My wife takes a ton of pictures. Actually, it's me taking the picture because she's usually the one in the pictures, and my daughter. And here's some pictures of us going out, like near my house. It's like 2 miles from my house, and we go to a farm. And every year around this time, April or May, we pick up strawberries, and they give the buckets, and we put our strawberries in buckets, and then we take them home. And that's kind of a good activity if you plan to move here in Raleigh. That's one of the things that you'll be doing here. So one of the things that my wife, like I said, takes a ton of pictures, put them online, and you can visualize here like put them in a mobile app or mobile application or a website or a platform. One of the things that if we're going to build an application, for example, if I'm going to build an application for her to store the photos, she wants to keep track of the views and the likes. And when we talk about data, the data could be the pictures that we want to store in the cloud because it cannot live in the phone, right? We want to share them with our family. But that data, I need to save them somewhere. So since we're talking about DevOps and clouds, let's use the example of put them in object storage, and in this case in a bucket. But the other part that I need, if I'm going to build this application, I need a database, like to keep track of the likes and the views of that database. So the app is getting a little bit more complex. So there's always data associated with your application. And for folks that develop applications, it could be containers, it could be serverless, you also have source code. And one of the things in DevOps that people don't talk about a lot is who's backing up the Git repos, right? Everybody talks about the data of the application, but also source code is stored also in object storage. They have databases. It's just we delegate that to managed services. For example, a Git server from a cloud provider or GitHub. But for this talk, we're going to talk about my application. And there's been a few talks here about Kubernetes. So this is kind of a Kubernetes 101. I talked to a few folks during lunch, and some of them told me, like, I don't want to know anything about Kubernetes. I just want Kubernetes just works, and somebody else takes about that. But this is kind of the typical pipeline of Kubernetes. Of you put your source code, you have your CI pipeline, and I usually separate CI from CD. So CI takes care of building the container image and putting in a registry, and that ends there. And usually that's the pattern that I recommend. Then comes the part of CD. And CD, the new trend, I've just seen some talks yesterday actually on GitOps, which is a good thing. They gave you the GitOps 101 of putting your source code, manifest or configuration, source code as code in Git, and then having a CD pipeline. And some folks will have it like imperative flow of using something like Jenkins, but also we also have GitOps, where GitOps will pick up the contents of Git and then reconciles that into the application, and the application gets deployed in Kubernetes and by pulling the image. So this is just kind of one-on-one if I want to build that application. I want to run it in a container, and then I choose Kubernetes. That's that I work, one of the projects that I work on. So what happens there? So let's talk about CD. There's a lot of talks about CI. So in this talk, I'm going to talk about GitOps. So in GitOps, when you have your code being pushed into the Kubernetes API, in that case, you're using it to deploy your application, and the application always follows what is in Git. So that's kind of the normal thing of using GitOps. And these are the two of the tools that do GitOps, and both tools are very good. Both tools recently graduated as CNCF projects. So for those of you that don't know what CNCF is, a Cloud Native Foundation where hosts projects like Kubernetes. Kubernetes is also a graduated project. There's a few projects that are graduated. There's different levels of CNCF graduated projects, but Flux and Argo CD are the two, I would say, most popular ones, and actually becoming popular in the enterprise for customers doing applications in the cloud. So, but I said that my application, I can write it in Python, I can write it in JavaScript, I can write it in Go, I can tell ChatGPT to build it, right? But my application, like I said, it needs more than just Kubernetes, just that more than just a container running in a pod. It needs data. So where I'm going to put my pictures, it will be an object storage. Where I'm going to put my database for my likes and my views, who's going to handle that? Am I going to have a different pipeline for that part and then a different pipeline for Kubernetes? Yeah, some people do that and they're successful in that area. But let me see over here. So this is the typical, not typical, but this is what some folks do. They take some Terraform and for example, CloudFormation or some other tool of infrastructure as code that maybe they own or another team owns, but my application is kind of small, so I'm going to be owning both. So I would need to know a little bit about Kubernetes, a little bit about GitOps, get my app ready, but then I need to switch hats or switch tools and use something like Terraform and CloudFormation. But what about if I could use Kubernetes to provision the database and the buckets with my application as a composition, like both together? Like, what about if I can put in that YAML file that I put in Git that describes how much memory my application needs, what is the CPU that it needs? What about in there if I can put some extra information that says, oh, by the way, I need a database. Oh, by the way, I need object storage. So that's what we want to do, but Terraform and CloudFormation doesn't give me that. And there's other tools that will give me that capability that I want. Two projects that are open source. One is called ACK, which is AWS Controllers for Kubernetes. It's maintained by AWS, which I work for. And another project is from the CNCF Foundation, like I mentioned before. It's in Sandbox. It's called Crossplane. These two projects are controllers that run in your Kubernetes cluster that actually provisions infrastructure, and infrastructure meaning like cloud resources, and that can handle that GitOps pattern. So now I can put my files in Git, have something like Argo Flux, and then that will reconcile. So I can have that reconciliation in both sides. I can have reconciliation, and reconciliation is the act of how Kubernetes works, of if the desired state and then the current state. So it makes what is you want to you desire in Git or basically in YAML files or Helm or other tools. I will create that, but it also does the reverse. If somebody by mistake changes something in the application, it changes something in the database or the bucket, that controller would reconcile. It has the capability to auto heal and then make it so that it always is at the desired state. So that's kind of the pattern, and I was asking a few folks if they knew about crossplane, and some of you told me that you already know about crossplane. So this is a crossplane 101 for those of you that don't know what it is. And like I said, it could be ACK, it could be crossplane. Crossplane is just one of the examples. It's a CNCF project. So the way it works is we're building a platform, and we have a platform team. And this platform team wants to help me as a developer, give me that API or that user experience for a developer. What the platform team, in this case, if they want to provide this self-serving platform, move here, in Crossplane, you will create a managed resource, and a managed resource is basically a small YAML file, the same way you would define a config map, for example, or a deployment. It's a Kubernetes resource that they will put things in here. You will install in your Kubernetes cluster. In this case, this one says, I want a bucket. The name is test, and the policy is delete, meaning that this is probably going to be used for testing. Like it will create the bucket, you will do your tests, put files in the bucket, delete the files, and then when that CR or manifest file that was deployed gets removed, also deletes the bucket. For production, we will see that you can change that policy and it will be different. So this is where Crossplane comes in. And Crossplane, the way it works is it works through something called providers, similar to Terraform. Terraform has different providers. Terraform is comes as a CLI, but you have to come and bring up providers to actually talk to different APIs and provisions aspects of it. Crossplane has the same capability, has a plugin or extensible system where you can install in there an AWS provider. For example, to deploy things in AWS or another cloud. It has a Terraform provider. If you have a little bit of Terraform and you have an HCL file, you can put that in there and they would actually deploy the Terraform for you. Also Helm, if you want to compose, like for example in my application, the pod, the service, and the ingress, those type of things, I usually put them in a Helm. So you'll be able to combine that. And it will create the bucket and it will reconcile. So when the platform team starts building the platform, actually they're using Kubernetes as the platform framework to build a platform that they want to provide to developers. So they have a bucket, but they can not just give me a bucket, because usually it's a bucket, it's a identity role. That role needs permission, so it needs a policy. So there's a couple of things that I need. And actually I also need the database. So Crossplane provides a kind of a programming model that you can create compositions of, like, think of it like templates. So in my case, my app for my strawberries, right, it needs a bucket, but it also needs something like the database. And that will give me the database. So if they add in the template a database, I will get my database through Crossplane. And then I was mentioning the identity, right? In this case, in AWS, we call them IAM roles, IAM policies, all these things that they need to be created by the platform team. They can handle that, and also this framework, what it does is reconciles. So the dependency of like creating the IAM role before you create the buckets, creating the VPC in this case before you create the database so you can attach it to the VPC, all those things inside the framework, it constantly tries to reconcile until every dependency gets met, and then everything gets deployed. So there's no need for the platform team or for the developer team to figure out what is the order of things that I need to deploy, right? It automatically detects the dependencies. And then that's how I get the IAM role. So as they add things in that composition, they will start provisioning aspects of that. And that's my app. My app doesn't need anything else. It needs access, it needs a bucket, and it needs a database. So the platform team basically builds a composition. We can call them maybe templates for the developer to access those. So this is kind of like the platform view of the framework. They create compositions based on the type of applications that the developer team, or in my case, I'm the developer and I want to build this web application for pictures, I would need this type of composition, and they can install it in that Kubernetes cluster. So like I mentioned, the composition, I said like 3 things, but it would need more. Like in this case, if the Kubernetes cluster is going to access the database, that database needs to be attached to a VPC that my cluster can access, security groups, and so on. And this is where like developers that are like wanting to concentrate, and this comes from like the talk from today, early today, about platform. They want to concentrate on the code that they're writing, right? What is the Python code or the JavaScript or the front end and the back end that they're writing for the web application, because these are the type of things that they don't deal on the day-to-day basis. They want to have, in this case, another team deal with the platform, and I'm a consumer, me as a developer, and just a consumer of that platform. So all these things can be templatized or make a composition in Kubernetes using Kubernetes APIs and everything. If you're using some Kubernetes in your company, then the folks working with that will be comfortable using that. And then comes the developer. So how a developer will consume this? Do I need to have a long YAML file that has all these things in there and everything? Well, no, that's where the developer comes with a claim. So in cross-plane, there's a concept called claim. And who have used Kubernetes PVs and PVCs? Or persistent volume and persistent volume claims. So it's the same concept. The claim says, I want, in Kubernetes, like I want a 1 gig data, right? Storage for my application. And then Kubernetes will provisions a PV of 1 gig and give it to you. So in this case, the developer in my application, I built this one for my strawberry app to store my pictures from taking strawberries. And I say like, my claim will be a very short file that says, I want maybe 1 for production, 1 for dev. And today somebody said that you don't need another environment, but some people have staging. I'm pretty proud. So you will have 1 file like this. And these files I put, because I don't want to put everything in there, but I put like the most important thing. Like the policy for production will be orphan, meaning that if this claim gets deleted, I don't want the bucket to be deleted. It's like, that's the data that I want to protect. Then multi-availability zone for the database. Maybe I want to change the logging of the duration of the database access, because maybe I'm troubleshooting something. Maybe I do it in a different one. And then lifecycle days, or like how many days you want to keep the files in S3 hot before you move them to a cold storage class, right? Which it has a cost optimization aspect to it. So this is kind of the one way that if you use Kubernetes, you can build a platform for developers where they configure a simple file, like it could be a values.yaml or myapp.yaml, very short, to provision everything that they need, including the application. Remember that I said that compositions could have a Helm? So deploying the Helm and the data that they need. So once they do that, the claim will find the composition that meets those requirements, because there could be multiple compositions, different flavors of them, compositions that deploy on the cloud, different clouds, or just on premise. But in this case, I'm deploying to the cloud, so I'm picking up in my example, AWS provider, and creating that environment. And then you put them in one namespace and you get one instance. You create another namespace, maybe call it dev, put the claim file in there, and then you get another instance that you can delete and provision. So this is where we go into what I was saying, the orphan of the bucket and the database. Like if I delete the claim, I don't want stuff to be deleted, but what happens if I lose the cluster, or if I lose the database? So I'm doing everything through GitOps, but the one thing that I cannot do through GitOps is put my pictures in Git, right, and put my SQL statements in Git. Well, you can base64 everything and put them in Git, but it's not practical. So let's switch the story about data disaster recovery, meaning that you have to be sure that you keep and don't lose those likes and views from the database. And more important, if you don't want to get divorced, you don't lose those pictures. So in my house, I'm the IT manager of thousands and thousands and gigs of pictures. So if I have one job, it will be like, do not lose and back up the photos that we take in the family. So in this case, for data disaster recovery, there's a spectrum, and there's also a cost associated with it. You can have a strategy that is on one end, backup and recovery, meaning that I'm going to have one instance, and if something happens, I'm going to recover everything from a backup. Where the other string could be a multi-site active that is, I have live, I cannot go down for that amount of time, and I need to have the fastest way to get the application up and running. So when we talk about disaster recovery, I tend to say, well, it's a spectrum, right? So you have to look at the trade-offs. And for today's, I'm going to talk about backup and restore because it's my own app, it's on my own picture, so it's okay if it takes me a few minutes or a few hours to recover, but I need to back up. Let me see. Next slide. So let's see at the one of the examples, practical examples. So you can start, and I have two examples in here for today. I'm going to talk about one of them. And let's say that you have a Kubernetes cluster and you have it in a region or an area of the cloud, and everything's good. I'll take the database as an example. And you have your EKS cluster, Kubernetes cluster. It has etcd associated with it. And then Crossplane is deploying the database for my application. I'm putting my claim with my source code. It could be 2 Git repos. Usually that's the pattern, but in this case, we're talking about the manifest files. So we put them in Git, and then a tool, in this case, for this example, is using Argo CD. So Argo CD will see the claim that is sitting in Git, will send it to Kubernetes as a claim. Crossplane has a couple of compositions. It will detect that claim can be satisfied by this specific composition that will give me the database, the bucket, and my application, and it deploys the database. So everything's fine, everything's running, phase 1 of the project, and we celebrate. The second part is we need to have backups. And one way of doing backups in Kubernetes is backing up that data that is in etcd. And you can say that everything in Kubernetes is stateless, yes, but when it comes to backup and restore, and you want to back up certain metadata associated with that specific data that you have in the database, you want to back up. So Velero is one of the tools. There's many tools, actually vendor tools, that can back up that data that it sits in Kubernetes, meaning etcd. So Velero is an open source project that you can back up. In this scenario, you want to back up because you may expect to lose the database. So you back up that aspect using something like Velero. But Velero, in this case, can back up PVs and PVCs, but in my case, I have the database outside the cluster. So I will need to use the cloud provider capabilities to back up the database into whatever solutions the cloud provider gives you. In this case, we have S3 as a good storage for backups of the database. So that's one thing that you have to do. Back up your database and back up your Kubernetes etcd. And one of the things that I learned very early in my career when I was doing backups was, or maybe it was only me, was do you need to back up to a different place that actually the disaster is going to occur. And you've been surprised that people, in my early career, then I found that that's a simple mistake, that people do the backups, configures everything, and they back up to the same place or the same region that they have, that the disaster could happen. So that's one of the things that you can do is back up to a different one. So what happens is, so the next thing is, let's say that a region is not affected. Usually if a region is affected, it's because there's a hurricane or something like that. But let's say that somebody misconfigures something, or maybe the cluster is having trouble. I want to change something in my application, in my claim, and I can't on one region. Crossplane cannot access the database. Argo cannot access the cluster. So maybe the outcome of the decision making in that aspect is like let's create another cluster. We already have backups, so we'll create a new database, and everything, and the photos are already being replicated. So I lose the cluster, I just delete the cluster, don't worry about it because I have backups. The next thing is you can create a new cluster in a different region or in a different place, and then use Velero to restore that information. So you install Velero inside the cluster, connected to that S3 that you were doing backups, and then Velero will run in the opposite way, doing the restore of that, and then everything will go into etcd. One of the lessons learned in this aspect, when you do it, be careful that the configuration that was in the other one, and the other place, it has specific things to the region. So one thing is like the region name. Other aspect could be the subnet or the availability zone names may be different. So that's where you can use something like webhooks in Kubernetes, mutation webhooks, to actually compensate those delta when you back up. So that's one of the things that you have to be careful. The other aspect is let Crossplane create a new database. So in this case, you want to create a new database from Crossplane, and then you start doing your normal cloud provider restore to restore that database content into it. And then you can start, so at that point, the application is up and running. It can access the database. I can access the S3 bucket. And then if you want to make a change to the application, you would do it through GitOps. Well, guess what? When you create this type of platforms or interfaces, you don't think about backups and moving them to a different region. So sometimes these YAML files have specifics on the region, have specifics on the availability zone. So when you hook up Argo, maybe you have a lot of files sitting in Git, and you have to also compensate in that side. So I would say that's another practice, to use mutation webhooks from Kubernetes. And these mutation webhooks, you can do them as simple as creating a web app with a webhook, or you can use tools like Kyverno, for example, that can do policy-based mutations. And that's basically how you recover a product. And this is a typical questions that I get all the time when people start with Kubernetes and start with GitOps. They ask me like, well, how do you recover? How do you recover stateful applications when you run in Kubernetes? This is one way of doing it, right? It's a two-stage process. You have to back up. Like I said, I didn't talk about backing up Git because I'm usually using a provider, but you have to back up your data. And that's the most important thing. Here's some resources. This specific scenario comes out of like 3 scenarios that are written in a blog post. That is recovery when using Crossplane for infrastructure provisioning on AWS was written by my team. There's 3 scenarios in there. Links to Crossplane, Velero, and Argo CD, which are the projects that I use for the scenario. And then we have EKS blueprints, which is also for my team in AWS, that we provide examples and best practices on how to deploy EKS solutions, base solutions, going from data on EKS, using Terraform, using CDK, using Crossplane. So if you're using AWS, you can get the resources there. And I will finish with that. The lessons learned about this is always backup. Test your backups, like they said in a previous slide. It's always a 2-step recovery, the data plus the metadata. And support your local farmers if you live here. So always make sure that your UC data is always backup. And I will finish with that.